Forget that. We can ignore that. Now let's fill in the blanks. 200 equals 0.5 times, I'm not going to put a negative, 9.81 times t squared. I do not have the t. It's okay. I can solve for this. 200 equals 4.91 times t squared. Divide by 4.91, cancel. Divide by 4.91. T squared equals 407. Not my answer. Square root it. T equals 20.18. Not my answer, just my t. So I'm going to come over here and I'm going to say 20.18. 20.18. Now I can use the the x component equation, which is d sub x equals v sub x times t. The distance is, I don't know. The velocity is 100. The t is 20.18. Multiply those numbers together. What distance do they need to release so that way when it forms the parabolic shape, it's going to fall exactly at that location? Well, multiply those two numbers. D sub x equals 2,018 meters away. That's my answer. Okay, I know you're exhausted. Again, I know this is a lengthy set of notes. This is a lengthy, very heavy unit to take in, but I know you can do it. We've got 2 practice problems. I'm going to highlight them because these are here for you to practice. If you don't tell me anything, I'm going to assume that you understand and got it. Okay? If you need to, we can maybe set you up or something. But I do need you to plug in and practice putting the numbers into the calculator on your own. Okay? We're not done yet. We're still going. We have 1, 2 pages, and then we're done. Okay? So, on my notes here, I'm just kind of hoping now that we've talked about it, this is another set of notes. Maybe here, this can just kind of help you out to, as like a refresher. Now, we've already talked about everything else. Let's go ahead and let's see the last bit of the notes here, which is kind of like a little summary notes of everything else that we've just talked about. So that's what it is. It's a summary notes. Okay? So let's go ahead and fill this in. And I'll zoom in for us a little less. Here we go. Projectile motion. So it says here, if you were to drop one object and throw the other identical object horizontally, which one will hit the ground first? So story has it that that on the Tower of Pisa, they went up there, Galileo went up there, and he tossed objects off, these like cannonballs. But they were the same shape and the same size, just different masses. And one was dropped and one was thrown out like, let me throw it out. And at that time, the Leaning Tower was not leaning then, okay? It only started leaning because down here, the dirt, they didn't know that when they built it, that there was sand down here below it, and it wasn't sturdy enough to hold this up, straight up, and then it started to lean, okay? So it took some time for it to start leaning, but they are, I don't know exactly if it was 5 years or 8 years ago that they were starting to construct and rebuild the foundation here, okay? So that's what the story has. This is my dropped ball, and this is my ball that was tossed out horizontally. Both balls right here start with no vertical velocity. This ball and this ball. Okay? The moment that both balls are released into the air, the only force acting on them while they're right here in the air what is it? It's gravity. And I'm not, again, I've said it before, it's not like a big gust of hurricane force winds. No, because now that's a force acting on it. When it's just a regular day and it's tossed into the air, the only force acting and touching them is gravity. So the moment that they are in the air, the only force touching them is gravity, okay? But that's when they're in the air. We also need to know that the magnitude of the ball's vertical velocity increases at the same rate. Why? Because gravity is not racist against anything. It's not going to be biased. It's going to pull on everything the same rate due to gravity. And because of that, they're going to hit the ground at the same time. Okay? So here's the ground. Number one, when are they going to hit the ground at the same time? In two conditions. Condition number one, they were released from the same height. Condition number two, they were released at the same time. So they will hit the ground both balls will hit the ground at the same time. Remember, under two conditions. If, number one, they were released from the same height, and number two, from the same time. Okay? Let's keep going. I'm going to scoot over here to the top part. Does throwing a ball horizontally affect how fast it takes the ball to reach the ground? Good question. One more time. Does throwing a ball horizontally affect how fast it's going to take for it to reach the ground? The answer is no. Not at all. The horizontal velocity does not affect the vertical velocity. Let me say it this way, and this is huge. They are independent of one another.
Stupid spider scared
Me too. Like, I don't know. So important. Guarantee you, you need to understand this concept. The moment you tossed, you are in your house and you have a second story, 2-story house, and you're on your room upstairs. You open up the window and you tossed a baseball out. Okay, you opened up the window. How about this? My kids did this to one of the other kids. One of my boys opened up his window from upstairs, and one of my other kid was outside in the backyard, and they shot the poor kid with the paintball gun. Okay? They did him wrong. They did their brother wrong. Okay? But the moment that that bullet of the paintball was released out of the paintball gun, that no longer, that horizontal velocity from the bullet no longer had an effect on when it's going to hit the ground. Why? Because horizontal bullet from the gun speed has nothing to do with the vertical of the bullet falling down. They are independent of themselves. The y-axis is independent of the x-axis. Okay? Whatever the x does with the velocity has nothing significance. So even though he wanted to, what if he got a faster gun that had a faster velocity? So it doesn't matter. This has nothing to do with how fast it was going to hit the ground. Okay? If you knew the velocity of the paintball coming out of the gun and you knew how high up you were, he could have actually told his brother to stand at a certain spot, and he could have shot it out, and he could have hit him exactly at that spot if he knew, if he was able to do the math, which he could. So let's keep going. Okay, because we're going to talk about this over and over and over, and this is huge, huge when it comes to physics. The next part here, it says definition. Okay, so projectile motion is the motion of an object due to gravity it has a parabolic shape and gravity is the only force acting on the object. Okay? So, projectile motion is the motion of an object due to gravity once it's in, what do we call it? Free fall. And it has a parabolic shape that it's going to take. And gravity is the only force acting on it. Okay? We have a little bit more, but I'm going to have to pause it here and then finish this part later on. But this unit is a good unit. I love this unit. Okay? All right. Have a good day.